In this tutorial, we're going to create a drill using Solidworks xShape, a cloud-based subdivision tool for freeform 3D modeling. The following topics will be included in this workflow. You can find what you need to get started and design along with us using the link in the description below. Opening the drill start file, we have 4 ordered geometrical sets, known as OGSs. The first OGS contains reference images of our drill, including a side and rear view. The second contains the trigger and chuck geometry. We will create our designs in the 2 empty OGSs named Handle and Battery. We'll start off by creating the handle of the drill, so let's activate the Handle OGS by double-clicking it in the Design Manager. We can add a primitive shape from the Subdivision tab on the action bar. Let's choose a cylinder and place it on the origin marked by the X. To position the cylinder, let's click Change Axis Direction until the cylinder is in line behind the chuck. We'll also enable the Crease Edges option to flatten the ends of our cylinder. We can adjust the number of segments, so we have 4 Z segments and 10 minor segments. Let's scale the cylinder by clicking and dragging the arrows. Note we can hover over the ruler to snap to precise increments. Let's drag the length of the cylinder to 130 millimeters and the radius to 35, and then click the green check mark. Next, let's focus on the bottom of the cylinder near the trigger. While holding the Control key, let's select the bottom 3 faces in line closer to the trigger and choose the Extrude command from the context toolbar. We can click the side of the orientation triad to view normal to our side profile image. To view our reference image as we sculpt, let's select Transparency from the top toolbar and set the slider to 50. Click the icon again to remove the slider. To extend the trigger area, let's box select the bottom group of vertices. Making any selection activates the robot manipulator, which allows us to translate, rotate, and scale any selection. By default, the robot is oriented based on our selection, but we can right-click the center of the robot to reorient to XYZ. We can then translate the vertices down in the Z direction by 50 millimeters. To add more control loops, let's select this vertical edge and launch the Insert Loops command from the action bar. In the dialog box, we can increase the number of loops to 3 and click the green check mark. Let's now box select the bottom 4 loops of vertices, then click and drag the scale point at the end of the arrow. Notice the selection is scaled relative to the robot's location, but we can move the robot itself. We can undo the previous scale from the action bar. This time, before scaling, click the center of the robot to deactivate it. Let's move the robot up 50 millimeters using the ruler, then click the center of it to reactivate the robot once again. Now we'll scale the selection down until the bottom face is just under the trigger, matching the image reference. To avoid editing the rest of the cylinder as we sculpt, we can activate the Working Zone command from the action bar. Let's box select the bottom 5 rows of vertices, excluding the back of the cylinder, and apply the command. To sculpt the trigger area, let's box select the middle 3 vertices and translate them inward by 30 millimeters. Next, box select the bottom front vertices and use the robot to drag in 15. To extend the rest of the handle, let's pan around to the bottom of the trigger area and hold the Control key while selecting the 2 bottom faces closer to the rear. Select Extrude from the context toolbar, then change back to a side view using the triad. Let's box select the bottom vertices and translate them down by 80 millimeters. We can insert several edge loops again by selecting this vertical edge and launching the Insert Loops command from the action bar. We'll set the number of loops to 4 and hit the green check. To flatten the bottom of the handle, we can hold the Control key while selecting the 2 bottom faces and choose the Crease command from the context toolbar. Let's translate the front edge forward by 30 millimeters and the rear edge back by 5. Double-clicking this edge selects the entire loop. We can translate this down by 10. With the edge loop still selected, let's launch the Crease command from the bottom action bar. In the dialog box, we can enable the Smooth Crease option and ensure the slider is set to 100 before clicking the green check. Notice xShape differentiates smooth creases in pink from sharp creases in dark blue. To sculpt the handle, we'll turn on Soft Selection mode, which allows us to extend the influence of the robot to neighboring vertices. In the dialog box, we can extend by a distance or number of faces away from our selection. Let's set this to a distance of 50 millimeters by dragging the slider or typing in the value. Let's box select the 3 groups of vertices behind the trigger and translate them in 20 millimeters. Next, we'll select this front edge of the handle and translate forward by 5. Then let's select this smooth creased edge and translate it back by 5. We'll continue editing the rear profile of the drill in Soft Selection mode. Let's use the Shift and arrow keys to rotate the model 90 degrees. Let's box select the middle 3 groups of vertices and scale up to match the image reference. To exit Soft Selection, close the dialog box. We'll complete the rear view by box selecting the bottom vertices and scaling them up to match the image reference. Next, we'll modify the trigger area to make it more comfortable. Let's click the reference image OGS in the Design Manager and select Hide from the context toolbar. We can then select the horizontal edge at the bottom of the cylinder and apply a crease from the context toolbar. If we select one of the sharp creased edges, the Tangent Propagation option from the context toolbar adds tangential edges to the selection. Note that clicking Crease Propagation will add all adjacent creased edges, which is not what we want in this case. With only the side and bottom edges selected, let's launch the Crease command from the action bar to change them from sharp creases to smooth creases. Let's set the slider to 100 before applying the command. The handle isn't complete yet, but we're ready to exit the subdivision environment from the top toolbar. Notice that the subdivision surface is automatically knitted into a closed watertight body. Subdivision surfaces can also be knitted by accessing the command from the context toolbar. To complete the handle, we'll subtract a portion of the rear using a new subdivision body. Let's insert a primitive box from the Subdivision tab on the action bar. Place the box in the center of the rear of the cylinder and decrease the number of Z segments to 2. In the dialog box, enable the Mid-Plane, Crease Edges, and Scale by Bounding Box options. Scale the shape to 100 millimeters in each direction and hit the green check. Let's change to a side view and use the Ctrl-A keyboard shortcut to select the entire active subdivision. Translate the box toward the back of the drill by 30 millimeters. We can double-click one of the middle edges to select the entire loop and choose the Crease command from the context toolbar. Let's translate this edge loop down by 15 millimeters and back by 10 before exiting the subdivision environment. We'll subtract the box from the drill handle using the Combine command under the Features tab in the action bar. In the dialog box, we'll set this to Subtract, select the drill handle as the target body, and select the box as the tool body. Hold the Control key while selecting 3 of the back edges and choose the Fillet command from the context toolbar. Set the radius to 5 mm and our drill handle is complete. Now let's activate the battery OGS by double-clicking it in the Design Manager. New features are added to the active OGS. In the Features tab of the action bar, launch the Thicken command. Rotate to the underside of the drill and select the 2 bottom faces. In the dialog box, set the thickness to 45 mm and hit the green check. We can launch the Thicken command again to offset our outer faces. Select one of the new side faces and choose Tangent Selection from the context toolbar. Set the thickness to 10 mm and hit the green check. We'll add a chamfer to the outer edges from under the Fillet command in the action bar. Let's select one of the side faces of the battery and in the dialog box set this to a symmetric chamfer and set the width to 5 mm. Our drill model is now complete. Feel free to continue modeling and make this design your own. And if you'd like to see more tutorials, check out the Solidworks YouTube channel.